Hello interwebs, welcome to Let's Fix Computers. I've got a Harmon kardon Sat Nav here. Yeah, people still use Sat Navs. Not everyone wants to use the old mobile phones, but yeah, they've still got their place. USB port's broken. I'm guessing you all know what's coming next. So it's the end of the day at the moment, so I'm probably just going to do a teardown on this, and then we'll cut to the point where I either fix it or I have parts for it. Maybe to the point... Oh, there's a screwdriver. But before I left today, I just wanted to open it up and just see what I was up against with this. So let's open it up and have a quick look, and then I'll know whether I actually need to buy a USB port. I have suspicion that the port inside isn't actually broken, it's just broken off. It's a surface mount job, and surface mount connectors are a terrible idea on USB devices. So yeah, you've got to use through hole. It's the only thing that will actually stand up to the punishment. Right, I've taken off those screws. Let's pop that SD card out. 256 megabytes, thank you very much. Anything in there? How does... Oh, it's a switch. Whoops. Oh, it's a lock switch. Idiot. Very well then. Okay, let's just try... Can I lever this open from anywhere? Let's just get in with the prying tool and just give it a bit of a tweak. Yeah, that's starting to pop open. Whoop. Oh, not too deep. I'm not trying to actually pry it open yet. I'm just tweaking the case about just to defeat the clips. I'm not sure yet which part is going to come away from where. Okay, that's going across the top there. That top panel has just popped out. That's the antenna, I assume. I think we've got one more down the side there. There we go. Okay. Can we get that screen disconnected? Okay, that's got some tape across it. If I just peel back that tape... Right, that's really annoying. I'm actually going to have to gut the whole thing out in order to get to that port. That's okay. Man, that connector is just the right way round to be as awkward as possible to get to. There we go. Right, I've removed this tape that was holding the connector shut. Not really necessary, but they do it just because they can. And I'm just going to get some tweezers in there and open that connector and move that off. So what I just did with the tweezers was that connector was in the closed position, and I just got in and just flipped that up so the cable could come out. So there's our screen module. Nothing to see in there. It's literally just a touch screen and LCD. All right. Let's take some more screws out. We've got a couple of screws there. Just the two, maybe? That's on a cable. Right. So this bit is going to be a little bit awkward because these connectors stick into the plastic, so it prevents it from lifting out. I think this side is most likely to come free first, so let's pry from that side. There we go. Alright, speaker. Alright, and we're free. There's our USB port. Take a closer look at that in a sec. There's the battery, obviously. It's a 1500 milliamp hour. That's not bad. They've sort of maximized the space that can reasonably take up. That'd be quite easy to replace if one was so inclined. Right, let's take a closer look at where the USB port has snapped off and just see how bad that is. here comes the close-up. So as you can see, this is all surface mount, and there was, well, yeah, there was almost no solder holding that on. Like, there's no solder blob, there's barely any solder there. There's barely any left on the pads. This was, yeah, this was just cosmetic. I'm not in the least bit surprised that that has snapped off. There was no anchorage whatsoever on that. And for something that's going to get fairly roughly connected and disconnected almost on a daily basis, you know, just there was no way that was going to hold up for the lifetime of the product. The good news is that I can probably just resolder that. I don't think that port needs replacing. So we'll get in there with a soldering iron and we'll redo that. I wonder if I can remove this tin shield to give myself more space to work, because the tricky bit will be getting to the pins at the back. I think my soldering iron will get in there because this is mini USB, not micro USB. So it's, and really, soldering on this kind of level is quite easy. It's when you get down to micro USB and smaller that it starts getting really tricky. Micro USB is harder than it looks when you're starting out at like hobby level soldering. But mini USB, it's pretty easy to do really. As long as you've got a not awful soldering iron, you should have no issues with a mini USB port. So, right, I'm going to see if I can get this... I'm just going to see if this tin shield is soldered on, because if I can remove that, I'd have a lot more space to work. Right, and the answer to that is yes, that's soldered in place. So that guy ain't coming off unless I desolder it, which I don't really want to do. So yeah, I think we're just going to have to get in there with my TS100 and hope for the best. And also... Well, this pad is a little bit torn. However, also that entire area, you see all those little dimples there, all those little dots, it's all ground plane. So even though we've torn that pad, there's all of that is all metal. So there's still plenty to solder onto on the circuit board there. So if we resolder that and put some nice big solder blobs on each corner, I think we can re-anchor that and make it stronger than it was before. I believe that because we'd be going in with leaded solder, I believe leaded solder is also a little bit stronger. It's less brittle if my memory serves me. So that should also give it a much better chance of actually surviving. So cool, that's fine. Let's do it. Right, on second thoughts, I'm going to stay a little bit late and get this done. Might be able to just do this in one sitting. So the first thing I want to do, I want to take the battery out because the battery is connected. I might be able to just disconnect that, but I'm just going to give this a quick pry and just see how much it's glued down. Just see if this guy wants to easily budge, which I think it does. I'm just going to gently ease that off, trying not to bend it. It's being a bit rude actually. Yeah, it is going though. I really don't want to pierce that. Where's my alcohol? I'm going to squirt a little bit of alcohol down the side of the battery. That'll just destroy the glue in there. The alcohol won't damage anything else. It'll just eat into that glue. So I can just peel that guy off. Oop, there we go. It's made all the glue on the bottom of the cell go horrible, but that doesn't matter. We'll stick some more double-sided tape on that afterwards. And I'm just going to grab my hot air and just blow dry this. It's a bit chilly in here, so the alcohol is not evaporating on its own accord. So I shall just give that a quick air dry. Alright, soldering iron is warming up, so the first thing we need to do is just clear up this leaded solder and just clean these pads. Let's go in for the nice juicy close-ups. And I'm just going to run solder across all of this just to mix leaded solder into the unleaded stuff. Now I'll use some solder wick just to take up all of that solder and leave us with some nice clean pads. And got to be a little bit careful here, because when you have damaged pads like this, too much heat will just damage the circuit board even more. So you don't want to be too vicious here. Just do what you got to do and get out. Although given how most of this is all ground pad, I'm not expecting to have any major issues here. But for example, the signal traces and things like that, if you use too much heat with the with solder wick, you might just tear up the last traces, and then you're really screwed. I think we need some... I've just added in some flux as well, because the solder isn't flowing very well. It's melting, but it's just blobbing up instead of actually flowing into where I want it. There we go. Now with the flux in place, it's actually flowing into the wick and staying in there, which is what I want. I need to try one of those flux pens at some point, because you don't need a big splurge of flux like what I'm using. It's not necessary to use that much. I'm wandering off shot. Right, that looks nice. Okay, so now I think I'm just going to lay down some new solder and just try and go straight in. So I'm going to put some solder right on the back of these pads. Just a little bit. Not too much, because then the connector won't sit down properly. And now I'll just run the iron over the back of the connector and just try and take up the nasty stuff there. Remove the last of that pad and such. That's not moving. Let's put some solder on the iron and then try and just take off the remainder of that pad. There we go. Oh, and then I dropped it. Hopefully when I put the solder there, it should just flow to the legs, because solder wants to flow to metal. That's how it works. The solder will flow to the hottest metal. So you've just got to try and get heat into the pins, and the solder should just naturally move to them. There we go, that's better. Right, let's get... I'm going to get one pad soldered down, so I've got an anchor point. Yeah, that's just moved completely. This is why we're just going to do one pad at a time, so then I can now just reposition it, and it'll effectively be glued in place by the solder. Okay, that's okay. It hasn't really flowed onto that pin the way I want it to, but that's passable. That's enough that we can try and do the pins at the back of the connector now and see if we can actually get onto those. So I'm just going to go in with, again, a little bit of solder on the back of the iron and just see if I can get those in place. Don't know if you guys can really see what I'm doing here. I think this connector needs to move backwards a little bit. I don't know if I can still do that though. We're about to find out. No, those pins are in place because when I reflow that one, the connector doesn't want to move. So we are committed to that. All right, let's try that. I'll stick some solder on another pad and we'll do a continuity check. Sorry about me knocking the camera about all over the place at the moment. We're going for the close-up shots again. Got my iron the wrong way up. Sometimes find that putting a bit of solder onto the iron and then pressing it down is the easiest way to apply it. You should apply the solder directly to the subject, but as I say, sometimes this works better for me. I'm just holding it in place just to get heat into the connector. Because just because the solder is molten doesn't mean that the connector is actually up to temperature for soldering. And that's an easy way to get a dry joint when the solder has flowed around, but the connector could actually be loose inside the solder joint, and that's called a dry joint. That's what you don't want. I might go no guts, no glory, actually, because from the angle I'm at, I think those connections are good. Let's see if I can get you guys a mega close-up. This camera can function as a poor man's microscope. Yeah, it's not pretty, but there's electrical connection in there. I think that'll do it. Bearing in mind that realistically this thing probably only needs power. Theoretically, you want to be able to get that USB connection as well for updates and stuff like that. But like in the real world, no one updates their sat nav. That was one of the reasons why these things fell out of vogue compared to smartphones, because the maps never get updated on them, or you have to pay a ludicrous amount for the updates or something like that. It was pretty bad. Yeah, I'm going no guts, no glory, and I'm just gonna solder down the other pads. Putting an excess amount of solder in there, just so we've got as much contact as possible. USB ports don't need to be pretty, they need to be strong. Strong and stable. There we go, so we've put a nice big old solder blob. That one in the back right, I'm not entirely happy with. That looks like it might be a little bit dry. So you can see where that solder blob is actually holding on to the side of the connector, whereas that solder blob there, that one's it's kind of just sitting on top of it like a pillow. I kind of want it to stick to the side of it. So I'm just going to reheat that. Alright, that's not perfect, but that'll do. Like I said, my objective here is just to blob a bunch of solder down there, so there's some nice big solder blobs working as anchors. And that thing should be much more resilient to breaking off now. Let's get some alcohol on there and clean it all up, and then we'll give it a test. Right, and the isopropyl alcohol just cleans away all the solder and schmutz and all the slag that gets left behind. That'll do. Very blobby soldering work there, but functional is what we need. Right, USB connector. Oh, that'll do. I've got one here I can steal. So what I'll do, I'll plug a cable in and I'll grab my multimeter and we can check the pins on the USB end of the cable to the back of the pins. So let's just go into continuity mode. Beep beep. Okay, so what I'll do is I'll put my positive probe onto one of the inside pins there, and I'll probe the back of the connector to see if we get a beep from the corresponding pin. Not sure which one that'll be, so I'm going to guess. I think we're on ground at the moment, so basically, yeah, that's ground. So the other side should be 12. Yeah, that is not ground, that's good. I think, well, I'm not sure which way around it is, I can never remember. Oh, it looks like we don't have a positive connection there. I don't think that's working at all. Okay. Well, we didn't have a short circuit, that's for certain. And these pins are really hard to probe, so you know what? I'm just going to go for it. We'll plug in the battery and we'll see what it does. Actually, we can just plug in the screen and see if it lights up with power applied to it, and then we won't risk shorting out the battery, even though I'm fairly certain that there's no short circuit there. If we plug in the screen and give it power, we should see some kind of reaction. And if we get absolutely anything out of it whatsoever, we know that there's power being delivered over USB. And that's the objective here. Right, the battery is connected, but that is not drawing any power. So it looks like that's a no-go. And just for confirmation, I'll just probe the pins very cack-handedly. No, it just turned off again. No, there's not a proper connection there. Balls! Gosh heck it. Let's put a bit of flux in there to help me out. Aha. 100 milliamps, 200 milliamps. It's doing something. Is it trying to turn on? It is. It's turned on. Ba-ba! All right, turn off again. Power on. So we should see, like, charge voltage now. Nah. 380 milliamps isn't a lot, but then it's only a little battery. Maybe it just doesn't, maybe it just charges slowly. The other thing as well is that these old Sat Navs, they often use, there we go, it is working. These old Sat Navs, they often, oh, there we go. Nope. Oh, it jumped up for a bit then it went off. Where was I? These old Sat Navs, they sometimes don't charge and run at the same time unless you're using the specific car charger. And a lot of the old Sat Navs, like the TomToms and stuff like that, the car charger actually outputted 9 volts to the USB port, which was really dumb. And they did that so there was enough, so just to make sure that there was enough power there to drive the Sat Nav and charge the battery at the same time. But because you were doing that to a USB port, a lot of people would say sort of, oh, I can just use any USB charger, right? And it's like, no, they're using a non-standard implementation. They weren't even using a fast charge standard or anything like that. It was just 9 volts over USB. So yeah, don't try and run any other USB device off of a Sat Nav charger. It will probably end badly. So yeah, at any rate, this guy's floating about. There's obviously some power there. I think it's working. So I'm going to reassemble this and then we'll give it one last test. So I will unplug the battery again just to switch it off. and then I shall disconnect the screen again, and then I can put everything back into the body and put it back together again. There we go. That's better. Or is it? You know, I think that's got no power. Didn't seem to have that problem a moment ago when we were testing. It's gone back to flickering again. Okay, I'm going to leave this to charge, and I'm going to come back to it in the morning and see if it's come good. I think the battery is flat, which is why it doesn't want to turn on. Because, yeah, too much of the incoming power is just getting sucked in by the battery. So, yeah, we'll come back to this in the morning, I think, and I reckon it's going to be fine. So, yeah, I'll see you guys after the cut. The next morning, it's run the power bank down, so let's just try turning it on again and see if it lights up. Okay, that looks promising. Yeah, that looks absolutely fine. It just needed charge in it, so that's fine. The battery was flat, and as I mentioned, it can't charge. You can't charge and use it at the same time from a 5-volt USB source. So most likely that this is just like the old TomTom ones, where the charge input is 9 volts. It might even say on the back. No, not sure. Anyway, it probably does. Anyway, the point is that this thing works. So let's just stick that top on. And I'm not sure if this needs to go in first or last. Either way, let's just snap that into place and then press that all together. Right, and there we have it. It's all done with a nice intact USB port again. Thank you very much for watching, everyone. I'll see you all next time. Bye for now.